talk about right now in this particular video is to talk about how to graph a parabolic equation. We've seen in previous videos about families of functions like the most basic parabolic equations, y is equal to x squared, which we found to look like this, and we went through the process of graphing this. And this right here is called the vertex of the graph. The lowest point on the graph is called the vertex. And also in a previous group of videos we talked about how do I factor a parabolic equation. And we did that when we talked about how to go through the process of factoring. We said the first rule of factoring was take out the greatest common factor, and the second rule of factoring was determine how many terms it has. And it has 3 terms, so we had to do a process called reverse foiling. And we did a whole section of problems dealing with this. I think I gave you 10 to 12 of those problems to actually do on your own. Like in this case, we're looking at this, and we're looking at using reverse FOIL, so we're looking at what are the first terms of this equation, what can I multiply two things by to get 8x squared, and we said 8x and 1x would be a choice. So 8 and 1 as a choice. It's probably not my best choice. I'm going to go with 4 and 2. I called those the cuddly pair of numbers. They're closer together. So let's use 4x and 2x as our choices here. Then we get the factors of 5 are going to be 5 and 1 or 1 and 5. I'm going to use the correct numbers right here this particular time and get this because I know the middle term would be 10x and this would be equal to 4x, and I can get negative 6x if the 10 was negative. So those would be the factors. The very next thing I asked you to do after that was rewrite this and set it equal to 0, because if we're setting y equal to 0, we're going to find the x-intercepts. So the most basic things when we're doing plotting a graph, we're going to identify x-intercepts and y-intercepts. And we said an x-intercept can be found by setting the y value 0. And we know a y-intercept can be found by setting the x value equal to 0. So we're going to do that for both. So if we set this equal to 0, we will be able to determine what are the x-intercepts. And we're going to find those x-intercepts right now. So I'm going to set this product equal to 0, so that means 4x minus 5 has to be equal to 0, or 2x plus 1 is equal to 0. So 4x will be equal to 5, and x will be equal to 5 over 4, and 2x will be equal to a negative 1, and x will be equal to a negative 1/2. So my intercepts are going to be 5 over 4 comma 0, and the other intercept will be a negative 1/2 comma 0. Those are my x-intercepts. And now we're looking for the y-intercept, which we have not done yet. But in order to get a y-intercept, all I need to do is set the x value equal to 0. So this will be y is equal to, go back to rewriting my expression first. I'm going to set x value equal to 0. When I do that, this will be 8, 0 squared minus 6 times 0 minus 5. And very simply, this will be 0 minus 0 minus 5, which gives me a negative 5. So the y-intercept will be ordered pair of 0 comma negative 5. That would be my y-intercept. So I got my y-intercept of 0 comma negative 5, and my x-intercept is equal to 5/4 comma 0 and negative 1 comma 0, negative 1/2 comma 0. And those are my x-intercepts. And this is my y-intercept. Now this is an important skill to have, so we want to be able to factor, find x-intercepts and y-intercept, and the only other thing we're going to find is called the vertex. And we're going to do this mathematically right now, then we're going to do it using our calculator. And we're going to graph this mathematically, and we're also going to use our calculator. So to find the vertex of a parabola, and that would be a negative b over 2a, and our standard form would be x squared plus bx plus c equal to y. So what we're going to do is, in this case, we'll have y is equal to 8x squared minus 6x minus 5 is equal to y. And negative b over 2a in this case will be a negative b over 2 times a, and a in this case is b is a negative 6 and a is an 8. So this will be equal to 6 over 16, and if I reduce that to lowest terms, that would be equal to 3/8. So what we can do to calculate the y value when x is equal to 3/8, one of the ways we can do this is simply use functional notation. F of x is equal to 8x squared minus 6x minus 5, and we do f at 3/8. This will be 8 times 3/8 all squared minus 6 times 3/8 minus 5. Let's use my calculator to do this work for me. So let's go to the calculator right now. So we're looking at the calculator, and what we're going to do is I'm going to graph this thing. So I'm going to push in the button y equal, and we'll see on the calculator once we turn it on, we will have nothing in there whatsoever. So I'm going to put in 8x squared minus 6x minus 5. So it will look like this when you plug it in. That would be a 8x squared minus 6x minus 5. And then on the calculator, we get to that by doing y equals. So we'll type in 8x squared minus 6x minus 5, and then we'll hit graph. Probably going to suggest that you have your window set up to be from the y minimum would be a negative 10, y maximum would be 10, our scale would be 1 unit, y minimum, this says a negative 15, and a y max to be a 10. If we did the graph of that, we would see that the graph would appear on my calculator if I actually typed it in, but I did not. So this would be 8x squared minus 6x minus 5, and we'll get a graph of this to appear like this. So if I did the graph, it would appear like this, as we would expect. So what I'm going to suggest that we do now is, on the graph, we're going to actually identify what our x-intercepts are. And that would be, we did what the x-intercepts were, which would be 5/4, 0, so it would be a little bit more than 1. 5/4 would be right here, and I could write 5/4, 0, and this would be equal to a negative 1/2, 0. And those are the values that we got when we did this, x-intercepts. And y-intercept, we got 0, negative 5, so if we look on this graph, we can see 0, negative 5 would be about right here. Now, I'm going to let my calculator do a lot of this work for me at this point. So, I'm going to go to the calculator again. I'm going to do, using the second button. The second button is this blue button right below y equal. We'll do second calculate. Second calculate. When you do second calculate, and calculate is the blue code, or the blue second calculate is the blue written CALC right above the trace button. When you do that, you'll see something called value as a choice. We're going to do this 2 ways. The first way is going to be value, because I know what the x value of the vertex is. It's equal to 3/8. I'm going to let the calculator come up with that value for me. So once I do that, second calculate, I'm going to choose number 1, value. I'm going to plug in 3/8. So then it'll come up with x equal to, and you will type in 3/8, in for the x value and let the calculator do the rest of it for you, which would be when you push enter, it will actually evaluate 3/8 to be 0.375, and the y value will be a negative 6.125. If we look at my graph that we've identified so far with some of the values here, we know that the vertex is going to be 3/8 comma negative 6.125 based upon my calculator findings, and it looks like it'd be a very logical find in terms of my graphing calculator doing the work for me. Another way to do this, same type of thing, is to do second calculate one more time, but instead of using value, let's use minimum. And it will ask you some questions. Once you hit minimum, it will be left bound and right bound. Okay, so when we're doing a left bound, will be the first choice. We're gonna use our cursor, and our cursor is going to be this button right here. We're going to use the to the right and to the left. We're going to choose our cursor to be to the left of the vertex. So it'll be left of the vertex. So I'm just going to move my cursor to the left of the vertex. Then I'll push enter. Then it'll come back and say right bound. And I'm going to move my cursor at that point, again using this button right here to move it to the right of the vertex. Then I'll push enter one more time, and it will come up with a response saying guess. And what we want to do is enter that one more time and let it pump it in for us. So we'll put a left bound, we'll have our cursor to the left of the vertex. Then the next thing will be right bound, we'll move our cursor to the right of the vertex, and we will use these buttons. And then after the next time it'll say guess. After you hit the enter button one more time, it'll say guess. And I don't want to guess, I want to push enter. And once you push enter one more time, it will come up and give you the value of the vertex, which will be right here. And it'll say 0.3749999, and previously we did this and we got 0.375, which is equal to 3/8, and we got y value to be negative 6.125, and that would be the y value of the vertex. So now we have the vertex of that graph already done for us using the second calculate minimum choice, and we could have also used second calculate value, where we put in 3/8 or 0.375 and it calculated negative 6.125 for you. And then you can identify your graph and identify the vertex, and you can identify the x-intercepts, which we did already, and the y-intercept. So that's graphing a parabolic equation and finding the x and y intercepts by x-intercepts by factoring, and the y-intercept by plugging in a 0 in for x. And after we factored, we set each one of the factors equal to 0, and that will give us our x-intercepts. And then we plug in 0 for x, and that will give me my y-intercept. So every one of those practicing questions that we had previously about factoring, that will give you additional 11 problems where you can do this same skill process to calculate what the graph would look like and what the vertex is, and check your skills on using your calculator. And those are great skills. In order to get really good at doing this, you want to do that multiple times, and using those same problems would be great problems to choose from to find the vertex, x-intercepts, and what the graph would look like.